Hi, I'm Professor Goins. In this video, I'm going to consider or discuss the concept of Taylor polynomials. So the Taylor polynomial of order k of f of x at x equal to a is given by the following. The sum n equals 0 to k, the nth derivative at a over n factorial times x minus a to the power of n. Okay, so what I want to do is let's run through an example of computing a couple Taylor polynomials, and then let's graph them as well to get an idea of not only how to find them, but then what are they representing? So let's take a look at the cosine function at a equal to pi, and let's look at the Taylor polynomials of orders 0, 2, and 4. So the way you're going to do this is whatever the order is, I'm going to make my table with n going up to that value. Okay, so n is going to go from 0 to 4. And then the second column here, I'm going to differentiate the function. So 0 means no derivative, so that would give me the cosine. First derivative is negative sine. Second derivative would be negative cosine. Third derivative then would be the derivative of negative cosine, which would be positive sine. Derivative of sine would be back to cosine. All right, then what I'm going to do is I'm going to evaluate the nth derivative, so evaluate these functions at pi. Cosine of pi would be 1, negative sine of pi would be 0, negative cosine of pi would be negative 1, sine of pi is 0, cosine of pi is 1. Wait, hold on, sorry, change those signs. And then I'm going to elaborate as to why. Remember that when I plot the angle pi, make sure that's on screen. When I plot the angle, that might not be on screen, let me do it over here. When I plot the angle pi on the unit circle, that puts me over here, which has an x-coordinate of negative 1. So that should have been negative 1, 1, and negative 1. Okay. For the Taylor polynomial of order 0, so again, what I do is going to use a sum from n equals 0 to k. So in this case, k would be 0. So this would be the nth derivative, so the 0th derivative at 0. So again, let's just do it this way. This is going to be f 0th derivative at 0 over 0 factorial, and then that's x minus pi to the 0. Nth derivative at 0 is negative 1. 0 factorial is 1. Anything to the 0 power is 1. So the Taylor polynomial of order 0 of the cosine function is negative 1. Okay. So again, we'll see intuitively or what that's representing here in a few moments. For the Taylor polynomial of order 2, so what I do is that's going to be the term from n equal to 0, which is this one, plus the term when n equals 1, which is going to be 0 because nth derivative the first derivative at pi is 0. So your second term in the sum would be 0. So I would have negative 1 plus, this is when n equals 0, this is when n equal to 1, and then plus when n is 2, that would be the derivative would be 1 over 2 factorial x minus pi squared, which would reduce to negative 1 plus a half x minus pi squared. So this right here would be your Taylor polynomial of order 2. For the Taylor polynomial of order 4, it's the term when n equals 0, which was negative 1, plus the term when n is 1, which is 0, plus the term when n is 2, which is this one, or the 1/2 x minus pi squared. So this is n equals 0, n equals 1, n equals 2, n equals 3, it's going to be 0. Because again, this is a factor, right? The derivative evaluated as a factor, so it's going to be 0. And then the last term when n is 4 would be minus 1 over 4 factorial x minus pi to the 4th. So when you rewrite this, you'll just drop off the zeros, but you're going to have the first term, this term, and this term. All right, so then if you want to look at what those are representing, again, I'm looking at the graph of the cosine function when a is equal to pi, which pi would represent this point on the graph right here. Let's graph these three functions. T0, so that's the Taylor polynomial of order 0, which is the graph -1, or y equal to -1. Okay. This quadratic right here for T2 would look like this. T4 actually, let me do those as a solid line. Maybe thinking it'll show it better on screen. So, what do we observe? The Taylor polynomial of order 0 is the tangent line. Taylor polynomial of order 2 is the best quadratic approximation. Taylor polynomial of order 4 is the best fourth degree approximation. And you can even see that, so from going from 0 to 2, these polynomials are essentially starting to wrap themselves around the curve. So from here, it's like I wrapped this line up this part of the parabola, or sort of a parabolic shape, and then when I take in more terms, it starts to follow along the curve a little bit more, past. So notice that here kind of separates, and then it starts separating above the horizontal axis, whereas here it starts to match it above the horizontal axis before it starts to wrap around. If I were to keep taking more and more polynomial terms, what's going to happen is these red curves are going to approximate the polynomial farther and farther out. They're going to start wrapping along and matching the graph. Keep that concept in mind when we start looking at what are called Taylor series, which you'll see in another video.